Okay, so good morning, good afternoon, and good evening. I am Charles, and I'm going to be presenting my topic on nanotechnology. Here are the table of contents. I'm going to be walking you through it one by one throughout the whole presentation. So, the Internet of Things, also referred to as IoT, refers to a network of physical devices, vehicles, appliances, and other objects that are embedded with sensors, software, and technologies to connect and exchange data over the Internet. These devices can collect and share data with each other, often without human intervention. Some examples of IoT could include smart home devices such as thermostats, lights, and security cameras that can be controlled by smartphone apps. Some examples could also include wearable health devices such as fitness trackers or smart watches that monitor vital signs and activities. And some examples are also connected vehicles where cars monitor and report on fuel efficiency, engine health, or even provide autonomous driving feature. Moving on to nanotechnology, nanotech is the study and application of materials and devices at the nanoscale, typically ranging from 1 to 100 nanometers. To put this in simpler perspective, a nanometer is equivalent to 100,000 times smaller than the width of a human hair. At this incredibly small scale, materials behave in unique ways, exhibiting properties such as enhanced strength, improved electrical conductivity, increased reactivity, or superior thermal resistance. These unique properties arise because at the nanoscale, the surface area of material become much larger relative to their volume, and quantum effects start to influence behavior. Scientists and engineers can manipulate atoms and molecules to create structures and systems with precisely tailored characteristics, enabling groundbreaking advancement across various fields. Security and privacy. Security is critical in nanotech IoT connected devices. Here's why. Here are the issues. First issue is sensitive data handling. Nanotechnology involves critical data like biological, medical, and environmental information. Unauthorized access or tampering could threaten privacy, medical care, or national security. Second issue is device vulnerabilities. Tiny nanotech devices are harder to secure physically and digitally. Their size allows undetected compromises, posing ongoing security and threats. Third issue is complex interaction with other IT networks. As part of IT systems, vulnerabilities in nanotech sensors can spread across networks, risking misdiagnosis or faulty treatments in smart healthcare setups. Fourth issue is constraints of resource. Limited power and storage in nanotech IoT devices hinder robust security measures like encryption, leaving them to more prone to cyber attacks. Now we go over to the activities of security and privacy in nanotech IoT devices. For the vulnerabilities, it is potential misuse of nanotech and weaponization. Nanotech could enable undetectable biological, chemical, or nuclear weapons or misuse medical nanorobots for espionage and sabotage. Malicious use of nanomaterials could harm safety, health, and the economy. Next is the security threats or cybersecurity risk. Some risk could include device hacking. IoT connected nanotech systems like medical or industrial tools are prone to hacking, risking harm and disruption. Hackers could steal property designs and sensitive medical data, leading to financial loss, identity theft, or industrial sabotage. And lastly, we have the privacy or privacy risk. Some privacy risks include biometric data exposure, where wearable and implants collect sensitive data, vulnerable to breaches and unauthorized surveillance. Leaks of nanotech research data could stifle innovation and provide competitors with an advantage. So here are the future development in nanotech security and privacy. First point is secure communication protocols. Nanotechnology supports lightweight encryption for nanoscale devices, while quantum communication offers tamper-proof data transmission for critical sectors like defense and healthcare. Next point is nanomaterial-based security systems. Nanomaterials enhance security with tamper-resistant coatings, unclonable nanoparticle-based tags, and improve biometric accuracy, ensuring resilience to physical and digital threats. Next is the nanotechnology in healthcare security. Nanotech improves healthcare with nanosensors and targeted drug delivery systems, securing these devices with encryption and anti tampering nanomaterials to protect patients' data and ensure the reliability of life saving technologies in medical networks. And lastly, we have the AI powered security for nanotech networks. AI fortifies nano IoT systems by detecting anomalies, predicting vulnerabilities, and adapting in real time, ensuring strong protection and critical infrastructure. So, in conclusion, we have learned that the term IoT stands for Internet of Things. It is the collective networks of physical objects, interrelated devices, appliances, and more. We also learned that nanotech is a science and engineering field that prioritizes designing and producing devices and objects. It is done by manipulating molecules and atoms to nanoscales. We also learned that security and privacy is a must in nanotech departments, especially in IoT connected nanotech devices and projects. Here are the references I used for this presentation. Thank you for your time and have a nice day.